Welcome everyone. In this program we are going to code the image processor class which stores an image and allows various manipulations on it. Now this image, all of the image, the JPEG image, your birthday photo image, or even the image that is appearing in your monitor right now is stored as a 2D array of pixels. Now pixel is just a dot with a certain color on a screen, so infinitesimally small in size that you cannot determine two dots apart. And when you see from very far away, like in your monitor, the dots are so minute you cannot see them with your naked eyes, and when you see the monitor, all the dots fuse, their color fuse so well that it feels great. It feels like the image which you are seeing right now in your computer. And so pixel, for the purpose of this program, pixel will be another class, will be already implement. We have to do nothing about it, and its implementation like kind of shown here. So there will be a pixel, it's a constructor with the R, G and B values. Now these pixels, they can generate all of the colors which a human eye can perceive using just a red, green and blue light. You can assume pixel like a box with a red, green and blue LEDs, and this box you make it very small, then you get exactly what a pixel is. And so it has accessors to get red and blue green and mutators to set red and blue green, and all the other instance variables and methods are not shown. And now each pixel is a combination of red, blue, green color, as I told you, and they mix along with each other colors to produce a dot of a color on the image. And this image processor class stores a 2D array of these dots or pixels as the image. So as you can see, it has a 2D array of pixels and another object found in another class, and that is named image. It has a height, it has a width, and this height or width are not in centimeter or inches. Height is in the number of pixels, width is in the number of pixels. And there is the constructor, we need to do nothing about it. And there is the flip horizontal, flip vertical, black and white image, rotate left, rotate right, and get image size methods, which we are going to talk about. So the first question, we have to implement the flip horizontal method, and it will flip the image horizontally and then assign the new image to the variable. Flipping horizontal would be like this, making an image may go like this image go like this. This is what we have to implement in flip horizontal. And suppose this is our image, and each image in a box, each image is a 2D array of pixels. So this is row 1, this is row 2, and in row 1 this is row 1 column 1, and I mean row 0 column 0, sorry. And in this we have this, a pixel with R value of 2, I mean red value of 2, blue value of 2 and green value of 2, and like this it is 6 pixels. So when we flip horizontally, the pixels on this edge go to this edge, this pixels on this edge go to this edge. As you can see, these two get swapped, and like so it spread inwards until it reaches the middlemost layer, which kinda stay the same, or you get the meaning what the flip horizontal mean. And we have to implement this not by using any other method like rotate left, right or flip vertical. Actually it can't done also with these. Next, in question number 2, we are going to implement the black and white image method. An image is black and white when the pixels are in the shades of gray, and the pixels are in shades of gray when their R, G and B values are equal, their red, blue, green values are equal. And to convert an image to a black and white image, all we have to do is to make the red, green and blue value of the pixels to be equal to their average value. So you take the R, G and B values, compute their average and assign their average to all of the variables. So R, G and B will have the same value, which is the average of the previous values. And now this new value, which is actually the average, will be a shade of gray. And when every pixel will be a shade of gray, the image will become black and white. As you can see, 10, 20 and 10. The sum will be 40 divided by 3 give us like 13.3, and so we assign each pixel the value of 13, the average, and we have turned it just into a black and white image. Next we move on to the question number 3. We are going to implement the rotate left method, which we have to implement without using any other method or classes in the image processor class. And this method would rotate the image stored in the image variable like this. It will take an image and just rotate it. it will like this, take an image and it will rotate it. So rotate rel is doing good to do all this, like just as I shown you. If this would be the image, rotate left would make the image go like this, and this is what we have to do with the rotate left method. Question number 4, we are going to implement the rotate right method, but a bit differently. This time we have to only use methods already present in the image processor class. So think over it, what all methods are going to help you in rotating right? That is maybe like a bit of a puzzle to you. And finally we are going to implement the get image size method of the class. We are going to assume that the size of a single pixel is 3 bytes and 1024 bytes make 1 kilobyte. Actually there is a lot of controversy in this, that 1000 bytes make 1 kilobyte and 1024 bytes make 1 KB, but for the purposes and sake of this video we are going to assume that 1024 bytes make only 1 kilobyte. And we are going to return the size of an image as a string when the function is called using this information. The size of the image is just the sum of the size of each and every pixel in the image, and the size of each and every pixel in the image is 3 bytes. So like if the size computes to be like 1050 bytes, we are going to return the size of the image is 1 kilobyte and 26 bytes, and that's what we are going to do. This is what we are going to implement. So go over and watch the next video.